Okay, so I'm going to multiply 1 by 2, probably the easiest way to do it. So that will give me 10x plus 8y equals 62. Then what am I going to do? If I add them together, I'll get 20x, so I don't need to, I want to eliminate the x's, so I don't add them, I subtract them. But which do I subtract from which? If we look at these equations, if I do, because of this negative here, if I subtract, if I subtract equation 2 from equation 3, I'll end up with a positive number, which is probably the best way forward. So I'm going to do equation 3 take away equation 2. So 10x, take away 10x, gone. 8y minus y is plus y, so that gives me 9y. That might be where you go wrong if you have gone wrong. Be careful of that double negative. 8y minus y is plus y, gives me 9y. And finally, 62 minus 26 is 436. And then divide y both sides by 9, I get y equals 36 divided by 9, which is 4. Then I would substitute that back into equation 1 or equation 2 to find x. Okay? Yeah. So I'll leave you to finish that off. But we could solve that algebraically. Equation 3 I arrived at by multiplying equation 1 by 2. So I've now got a new equation, so I call that 3. Yeah, I'll look at equation 1, multiply that by 2, so 10x. Yeah. I'll just call that equation 3, that's all. Can you just put that on one side if you're not quite finished it? It's because I want to move on. But you can, I'm sure you can finish that off, okay? And it's a reminder of how to solve that algebraically. If we do that on autograph, what we do was plot those two equations, equation 1 and equation 2. So let's close this and open a new page. And literally plot those two equations. So the first equation, what was equation number 1? Somebody read it out. Yep. Plus 4y, yep, equals 31. What's it going to look like, somebody? 5x plus 4y equals 31. What would you expect it to look like? No powers on x and y, so straight line. There it is. Let's zoom out a bit so we can see it. Now I'm going to plot the other equation, so I hit the equation button again, and the second equation is, yep, okay, and I get 2 lines. Now the beauty of this graph, one of the advantages of this graphical method is I can automatically see that there is a solution. There is a point at which those 2 equations give the same answer, and that's at that point there. So instantly, if these lines didn't cross, I could see that, and I could say there's no solution. So if I am interested in that, the beauty of this software is I can now focus in on that point. I think we can see that x equals 3 and y equals 4, so confirming what we've sort of started to find. So you should find that x equals 3 and y equals 4 when you do it. Of course, if these weren't exactly on the 3 and 4, I could use the zoom box to arrive at the values for x and y. Okay. So put that in the notes. So we get our values for x and y. So we can solve it algebraically or we can solve it graphically. Here's another one. Which way would you recommend solving that one? Yeah. If you had to do it either algebraically or graphically, Sam, which way would you pick? Right, it looks a bit more awkward to solve algebraically, doesn't it? So I'd certainly try and plot that graphically to solve it. And I would do exactly what we just did. I type in that equation, 13.6x minus 21y equals and blah blah, and 12.6, and the second one, and then I'd look for where the lines crossed. Yeah, and zoom in on that point. Okay? So I can use autograph to solve equations graphically. Okay. So I can solve simultaneous equations, or I can plot functions in autograph. So solving equations. Name one advantage of solving simultaneous equations graphically. Right, yeah, one, you can see that there is a solution. You can see there is a solution. Another advantage? Yeah, it's quick. You don't have, particularly for awkward equations. Yeah, quick, particularly for hard or difficult equations. I mean, they don't need to be linear. It could be a quadratic equation or even higher order equation. I would probably fall back on the graphical method to solve it. Okay, so it's quick, particularly for difficult equations. Yeah, I know. I'm being very lazy, aren't I? Particularly. Have I? What else have I done? Oh yeah, yeah. You can see that. Yeah. Okay. Disadvantages. Okay. Right. Yeah. Disadvantages. I hadn't thought of that one before, really, but you're not using your brain. You need access to the software. Whoop, yeah, that's right. There's one other one, really, a sort of more mathematical reason for doing it. We didn't solve this one, but it would be very unlikely if x and y turned out to be whole numbers. I'd be amazed. Okay, so what would be the advantage or the disadvantage of the graphical method in this? Yeah, that's right. So difficult to be exact. Well done, Richard. That's exactly what I was looking for. If you solve something algebraically, you're going to get an exact answer. If you solve it graphically, it depends on how far you can zoom in with the software that's available, etc. You can get near enough the answer you want, and in an engineering situation, that's probably going to be good enough. But the algebraic method does give you an exact answer, which is useful.